Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and welcome back officially to making games once more. So last week was the, to borrow a term from the tabletop role-playing game world, episode 0, week 0, session 0. That is where I outline my plans for how the game development for this project is going to go. And today we are going to officially get to work on actually creating 3D wizard game. I swear I will have a better title for that than this by the end of the series. Names are hard, okay? So today we're going to be getting to some basic 3D stuff. I'm going to create a basic 3D camera setup. I'm going to have it fly around in the world. I'm going to load in a test object. The order in which I do these, I have been internally debating for at least the last 30 seconds, and I think I'm going to actually load in a test object first. I'm going to have that like rendering in the 2D world, and then I'm going to use that as a like a reference point so that we can see our 3D camera and we can see that it's behaving properly. I'm going to be using GameMaker for this, obviously. I'm going to be not using a lot of the built-in GameMaker systems for things such as views and cameras, but I will be using objects and events and all that sort of thing. Let's see. Before I begin, let me do the most important first step. Open a Windows Explorer window here, and I can git init, and that is going to initialize an empty Git repository. And I'm going to add that to GitHub Desktop. And we are going to commit the empty project. And this is arguably the most important step in whatever you do that a lot of people just don't do, and they should be doing. But that is going to be our initialized Git repository. Now let me actually get into GameMaker and create myself an object. We can call this obj_game. This is going to be our traditional central game controller object that a lot of people use in GameMaker games. It's not going to like contain camera code itself, but it will be the central object through which like the rest of the game runs. I'm also going to get rid of the background layer because I'm going to clear the screen manually. Let's see. I won't be using views, won't be using viewports, won't be using view cameras or anything like that. Let's see. I won't commit that yet because we've hardly done anything. Ah, what the hell? Yes, I will. So the way I've decided to go about doing this is actually, before I write any 3D camera code or anything like that, to load a 3D object into the game and draw it in 2D. And that's mainly so that I just have something to look at when I do get the 3D camera in, besides just a GameMaker tile layer or something. So that should only take a minute or two to get in. If you want to skip that part and jump straight to where the 3D camera code is set up, I will have a time code appearing on screen right now, and you can just navigate to that time or click on the chapter down below or something like that. I do realize that this is a little bit of a non-standard way to start a series like this, but the whole thing should make sense soon enough. So, the test object that I'm going to load in is just going to be a block. This is just going to be like a generic like crate block thing. This is what it looks like. This is what it looks like unlit. I'm not going to be running any fancy shaders on it yet. I'm just going to be putting this in the game world so that we can see where we are. I'm also going to need to load in... Did I close the Windows Explorer window that I actually wanted? Good job. Anyway, I'm also going to load in the sprite that we're going to be using as a texture. Let's assign that to its own texture page. I'm not going to be dealing with any fancy like OBJ parsing or any fancy like GameMaker D3D file parsing. I am going to be going straight to vertex buffers. This is one of those things, one of those external tools that I said I will be using quite a lot of without probably all that much further explanation. But if I go and just drag this in here, this is our untextured 3D model. I can export this with a particular vertex format, and we can just save that as a vertex buffer, which I've apparently already done. I must have done that while I was messing around like a half hour ago. And we can take this, we can stick it in the included files folder in here, and we can just load that into the game as a buffer. And I hope nobody is treating this as like a rote tutorial, as a thing that you have to do when you make a game. These videos are decidedly not tutorials, unless you count in the project management sense, which I sometimes do. So, and I'm going to move this around later on as I structure the project more, but we can say vertex format begin vertex format add position 3D, vertex format add normal, vertex format add text chord, and vertex format add color. That is going to be our basic vertex format end. I debated like removing things like the color attribute or the normal attribute and just generating the normals in the shader, but then I decided that it could potentially be useful to have vertex color or smooth normal or something like that, and that the extra bytes per vertex isn't really going to be that much of a issue to deal with. And this can be saved to a variable called vertex format. And next, I'm going to want to buffer load. What was it? I called it block single, right? Block singular. We're just going to buffer Windows. We're just going to buffer load this. We can create buffer from buffer. The source buffer can be that. The format can be self.vortex format. This is going to need to be an instance variable, isn't it? And we can vertex freeze. Not strictly necessary, but it generally doesn't hurt. And buffer delete the original buffer. And then in the, let's say, the draw event, we can, and I'm going to try to draw this some ways to the middle of the screen. Matrix set. We can put this at like, say, 200, 200, 0. Actually, you know what? You may have seen this earlier, but I'm going to be using Y as the up axis instead of Z for reasons related to using Unity as a 3D level editor, because Unity likes Y up. Rotation 0, 0, 0, scale 1, 1, 1. And when we're done with that, we are going to need to reset the world matrix, and in the middle, vertex submit. Self.block PR triangle list, and the texture can be sprite get texture, text block singular index 0, sum image 0. And this should draw us the block vertex buffer on the screen. And I'm realizing now that I don't know if okay. So we've at least got that, because using Y as the vertical axis and drawing the thing at like 200, 0, 0, yeah, that's still going to be on the screen, so we can see that. So that's something. We've got it rendering. However, I would like to create myself a camera. The way that I've been doing cameras in 3D and GameMaker recently is not to attach them to like an obj_camera, but to actually just like make a struct containing all the data, because we don't want the camera to, or at least I don't want the camera to automatically have behaviors of its own, but rather I want the camera to really be a collection of data. This is going to be group_camera is going to be what the script file is called. I really could just call it camera, couldn't I? Because I don't think there's going to be anything else in this code file. So some notes on code style on that note. For those of you who have not been around here very much, I always prefix instance variables with self. The short explanation is because I said so, just deal with it. The longer explanation is because sometimes when you don't do this, it gets confusing what the scope of a variable is. And people don't realize that until it's a half hour later and something in a variable isn't living in the scope that they think it is. So I always use self dot. Even if you would assume that the scope is implicit, you're going to see me using self dot. And for like object-oriented code, I usually stick with the GameMaker naming conventions for everything in the game that isn't a script. For scripts, I often will, but not always, prefix them with like group underscore, just to indicate that it's a collection of code. And struct classes, this needs to be a constructor, doesn't it? Struct classes will generally have a naming convention that's sort of C#-ish. So Pascal case for classes, Pascal case for public methods, camel case for like if I'm gonna pretend something is a private method, because GameMaker doesn't really give us variable access. All right. So cameras are going to have some amount of, like, some properties built into them. I'm going to pass these as parameters to the camera constructor. There's obviously going to be x, y, z, x2, y2, z2, x up, y up, z up. I guess while I'm here, I'll also define z near, z far, and there's the field of view and the aspect ratio. And some of these may look familiar to setting, like, creating camera matrices. And by some of them, I mean all of them. These are just going to be our default camera settings. Let's see, let's save these to instance variables. Self.x is going to be x. This is going to be a lot of just like rote copying stuff down. And that's going to be some of our default camera properties. We will use these obviously later to construct view and projection matrices. I'm also going to want to keep track of self.pitch, pitch, and self.direction. And that's going to... cameras, in addition to containing the view and projection matrices, are going to want to like be able to remember where they are and where they're looking, and in, I guess, what would you call it, this gyrospace, pitch and yaw. It's a little bit more helpful to keep track of these than simply the camera's orientation matrices. I'm also going to want to say self.camera is going to be camera create. This is when we say camera apply, when we set our projection, what I'm going to be applying it to. I have a limited amount of trust in like the default automatic cameras that GameMaker creates and manages, like the view cameras and whatever, because sometimes GameMaker might choose to do things behind the scenes to them and update them in different ways, which I don't really want. So we're not going to do that. I'm also going to define a few methods. This can be a method called set projection. Actually, you know what? It's going to set the view and the projection matrices, so I'll call it apply. And that is going to say, what is it? Var proj mat is going to be camera or matrix build projection perspective field of view with the self.field of view on the y-axis, self.aspect, self.z near, and self.z far. We're also going to save our view mat is going to be matrix build look at from self.x xyz x2 y2 z2 x up y up z up, and we can apply these. Camera set view mat self.camera the view mat, camera set proj mat self.camera the proj mat projection matrix, and lastly camera apply. And that only needs one parameter. Okay. So this is going to set our camera's projection based on all of these, you know, all these things. I'll get to like updating and moving around in a bit, but first I'd like to say in our game controllers create event, camera equals new camera. This is going to, do you really not recognize all of your parameters that you should be taking? GameMaker, code help, please. Oh, whatever. By long-standing tradition, my test cameras like to look from the world origin, some distance above the world origin, and just like across like 1,000 units across the room. So I can say X is going to be 0, Y, since we're using Y up, can be something like 250. Z can be 0. 2 can be, let's say, 1,000, 0 on the vertical, and 1,000 on the Z. And up can be 0, positive 1, 0. And what's after that? Field of view. Let's hard-code that to 60 for now. Aspect can be 16/9, hard-coded for now. I'll make these values nicer later on. Z near can be, let's say, 1. Z far can be 10,000. And in the draw event, we can say self.camera.apply. I'll get to clearing the screen momentarily. And that actually should be all we need to see this block on the screen. Alright, so can I do this on the first try? I cannot, because I misspelled projmat. That's not even the first time I did that. I misspelled it the first time too. And we can see that we have ourselves a block on screen. And it's not quite where I expected it to be. I expected it to be like closer to the floor. 200, 200. Oh, you know what? Is our camera upside down? I hate this. Game Maker, why do you force me to do such nonsense with 3D cameras? We'll just invert that. Okay, now that's where I expected it to be. So it's a little bit inside out. Maybe not ideal, so there's going to be a few things that I maybe should do, such as GPU set Z test enable, true. GPU set Z right enable to true. I also mentioned clearing the screen, so we can say draw clear C underscore black. And that's going to clear the screen and the depth buffer. At the end of the draw event, we can set these back to false. And clearing the screen isn't something you'll notice because there's no motion, but we've also got one of those faces looks like inside out. Oh, you know what? That's because that is the side of the face that actually is like doesn't have if I open it up again, one of these sides of this cube actually is like empty because I forgot to put a face there. That's the side that's usually on the ground. But we can turn on backface culling as well, so maybe it's not a bad thing that I was reminded of that. GPU set cull mode. We are going to want to remove the counterclockwise winding direction. And I think that should be okay for now. Is the default culling mode like on or off? It's no culling, okay. I guess I'll also set that back to color direction no culling so that the back faces aren't removed for like the UI and stuff, but hey, that's our basic 3D projection. Alright, real quick, let me off-screen repair that last missing face on these blocks because boom, done. It's a little bit awkward when just one of the faces of a cube like this is just like not there because I forgot to put it there. Okay. So, we can commit some basic camera stuff. I guess while I'm here, I can also start checking off certain cards on this. So, for example, load a test object, that's done. Vertex format, that's done. 3D camera setup. Did I'll finish these first. Where is the like set status? Oh, you know what? I'm really stupid. Okay, so it just says done cards go here. This is one of those things that I mean where, like, I feel like the card deck metaphor just gets in the way of itself sometimes. Like, I would really just prefer a big honking button up here that says mark as finished instead of, like, having to physically drag a card, like, across the play table mat thingy. But we can mark you as done, we can mark you as done, and that's gonna be some progress. Why is this on fire? Oh, that's like a streak. That doesn't apply to me because I'm not going to be working on this every day. But yeah, we can mark those cards as done. I can also start checking off boxes on here. So for example, 3D camera setup, use Y up, that's fine. Set the projection. Get view matrix, get proj mat. Okay, that's one of those little tasks that is sometimes useful for a camera like this. Self.get view mat. I can say camera get view mat, can't I? Camera get view mat self.camera. This can be useful if you want to do things like screen space transforms. Like this. I just know that if I don't do this now, I'm going to forget about it when I actually want to, and then I'll be like, wasn't there a camera get view mat function or whatever? And then I'll be like, have no idea where it went and be really confused. Some other stuff, draw skybox. I'll create a method for drawing a skybox later. That's typically something that you do before drawing anything else in the world, like immediately after clearing the screen. I do not have anything for skyboxes quite yet. I will eventually, at least for like maps that are supposed to take place outdoors. But again, I will just create a function for that and we can fill it in later. And possibly the most exciting one is going to be update. I call it update free, and I'll probably keep it around for debugging even after like there's the camera that can follow around the player and that sort of thing. This is going to take a little bit of work. So a lot of the code for things like this isn't all that different from project to project. You could probably just copy a bunch of code out of my like first-person character controller video from 3 years ago, and it'll just work. But I do want to say, we're going to have dx, dy, dz. Those are going to be the difference in x, y, and z positions. I'm going to say if keyboard check ord w, that's going to be we're moving forward. And we can say dx plus equals degree cosine of self dot direction. This also needs to be like the degree cosine of the pitch, doesn't it? dy can be plus equals the sine of self dot pitch, and dz plus equals the sine, or it's minus equals because sine is reversed. Minus equals the degree sine of self dot direction times the degree cosine of self dot pitch, and that should allow us to move forward at the very least. I'll also define like a var speed is like 4 or something like that. And then x plus equals dx times speed. Y plus equals dy times speed. Z plus equals dz times speed. And we should now at least be able to move forward. Or no, we won't necessarily be moving forward. We'll be moving like forward in the direction and pitch that we're looking. Alright, you know, maybe I should write out the rest of this first. So that's forward. Back can be the S key on the keyboard, and that's just going to be forward but reversed, but with all the signs reversed. Left, it's going to be A, and that is going to be, and I'm going to have to look at my notes for this one. We're not going to be modifying the vertical position when we move left and right, when we strafe left and right. But we can say that when we move left, x minus equals the sine of the direction, and z minus equals the cosine of the direction. And when I move right with the D key, it should just be that reversed, shouldn't it? And lastly, I'm also going to want to update x2 is going to be equal to self.x plus the sine of the direction, plus the cosine of the direction. Self.y2 is going to be... And I hate that I have to always refer to my notes every time I do this. But y2 is going to be self.y minus degree sine of self.pitch. Z2 is going to be z minus the sine direction, and I also need to remember to multiply by the d cosine, the degree cosine of the pitch for the vertical axes. Okay, so this is a first-person camera. This is really just for debugging purposes for right now. I am not calling the update anywhere, and I'm also not doing something which is that I'm not like updating the pitch and the direction. For example, to like center the mouse cursor or anything. I'm gonna say if mouse check button MB middle. So if you hold the middle click, then you'll like center the camera and look around. So to get the mouse's position relative to the center of the window, we can say var mx is going to be window get width divided by 2 minus window get mouse window, what is it, mouse, oh come on, window mouse get x. or my can be window get height divided by 2 minus window mouse get y. Self.direction plus equals mx. I'm going to divide this by like 10 just so that when you flick the mouse a little bit, you don't really completely send the camera into a spin. And self.pitch is going to be pitch plus my divided by 10. And we're going to need to clamp that between like -80 and +80. And then when we're done, window mouse center. No, window mouse set. Window get width, window get height, and these both need to be divided by 2. All right. This should allow me to... I'm still not calling the update method anymore, am I? I'll move that to the step event later. Okay, I really hope this works. Let's see, can I look around? All right, here we are. I seem to be moving backwards from what I think, but okay. So I need to flip some signs in here. I can say window mouse get x minus that. And that'll have me looking around in the opposite direction. All right, if I can find there it is. So that's that. And I still feel like some signs are flipped. When I hit A and D, for example, I'm going the opposite way that I expect I am. And looking vertically. Okay, so I'm gonna wanna... I might not have copied these out of my test projects perfectly. So switch the D and the A, and I feel like the sign of going up and down should be the other way. All right, so that's that. I'm flying around in space. I am perfect. All right, I've got a free cam. Hooray! I can like go through the box. You can see that when we're inside the box, we cannot see the faces because backface culling is turned on. All right, this is the beginning of a game. I've been recording for 40 minutes. Hopefully that'll be cut down to about a half an hour. This was a little longer than I really wanted a first video to be. I'll fill in the rest will draw skybox later. This was a little longer than I wanted a first video to be, but it would have felt weird to just leave any one of these hanging right now, I think. This is like a prototypical 3D project. I feel like if I were to make a game in the future, I could just like clone this project from the state that it's in right now and use that as a starting point and save myself a half hour of work. I may consider that in the future. This is like very, very fundamental. If you wanted to have a little bit more of a rigorous test example, you could draw a few more blocks in the world. And you could fly around those. But either way, we've got ourselves 3 3D shapes. We've got ourselves a 3D camera that you can zoom around and look at things with. Next time, let me make a commit. This is going to be free camera. I'm also going to mark this as the 0.1. I get to start doing this again. That's exciting. Let's tag 0.1 with many more to come, hopefully. So next time, I'm going to try to do what I did at the end of every Bullet Hell episode and describe what we're going to do next time. Let me go and set up like the proper Penguin import scripts so that I can actually arrange and collect and easily import my 3D models without having to like do it manually. I'm going to add a couple other test vertex buffers that hopefully won't take too long. Let me see. I also want to, at the end of every week, the same way that I did in Bullet Hell, show the progress board for what's gotten done. And it's not necessarily going to be like a nice and neat progression with a little bit of work being done each week and following the slope, because I am going to be recording these on a semi-irregular basis and trying to hope that I can work ahead enough to get an episode up a week. But already you can see that we've got a bit of a slope. We've got somewhat of a downward trajectory. That's exciting. In a few weeks, we should have a decent chunk of at least the first part of this game knocked out. I see there's some other metrics down here, which I'm sure I will also be looking at after a few weeks when there's actually data in there. But this is the beginning of our 3D wizard game. My name is Michael. I like wizards, as you can probably tell, and dragons, and making games. I try to post about 2 game dev videos a week, 1 of these and 1 tutorial. So if any of the weirder things you can do in GameMaker appeals to you, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. Otherwise, I hope you all are going to enjoy this, and I will see you all later. Special thanks to Army Armbuster, DJ Gibbles, Edward Holt, GameMaker, Harold Guidry, Keyexy, Manta Ray, Sindra Larson, Squarecrow, The Oz, VTRV, and Zenjamint for supporting these videos. If you want to support the channel, head on over to the Patreon page down in the video description to join the fun.